Abrupt intro. All right, right now, we're about to see the NVIDIA Keynote. Um, I'm not exactly sure what to expect here, but I'm kind of excited. I was thinking maybe they're gonna have a new NVIDIA Shield. Probably not, because I would imagine that would be more like a CES type product. But this is Computex 2023, and NVIDIA is having the keynote. Recently, they've had a real big bump in their stock price. A lot of that probably revolves around AI and how everybody's all going nuts about AI. So we're going to see what exactly uh, NVIDIA is going to be up to here. Now, I don't have the music playing, and that's mostly because I want to try and avoid any sort of copyright issues because I do not own the rights to it, and I'm kind of a little bit concerned about that. So we're just gonna let her roll right now, as is. And once somebody takes to the stage, we're gonna zoom up this volume so we can hear what they have to say. Now it's interesting because we just recently had a big release of information of cards from NVIDIA. We had the 4070, 4060 Ti, 4060, a lot of those details. Not a lot of real hot reception to that 4060 Ti or the 4060, but so like, all the low end ones. Now, there is a certain thing that I am expecting to hear about, and that is, where is it here? The neural texture compression. Now, this is something, random access neural texture compression or neural compression of material textures. So this is something that I'm pretty sure NVIDIA is going to start pushing as VRAM requirements for a lot of games start going crazy. So we'll see what they have. Um, they're probably going to talk about it. I wouldn't be surprised, especially for a lot of these 8 GB, even 12 GB cards that they have coming out. They're not necessarily going to be something that you're going to look at and be like, oh yeah, that's going to be playing games for a long time. Yeah, we thought about that back in 2020. Excuse me. But yeah, 10 gigs is just not enough. Sorry, 3080 owners. But yeah, and 12 gigs is just barely enough. Sorry, 3080 Ti and 3080 uh 12 gig owners. Yeah, so we will see. I'm pretty sure this neural texture or neural compression of material textures is going to be something that's going to come up, and they're going to chit chat about it. And I'm really excited to hear about that. But I am thinking there is going to be probably something to do with a new card, maybe not. So let's see. Who knows? Maybe there'll be a 3090 Ti, or not 4090 Ti. Who knows? But I'm pretty sure they're going to talk about probably graphics cards for probably for laptops. There might be a bit of a touch on that, but we'll see. We'll see. Let's see. We're almost there. Hopefully they're ready to take the stage. And before they do, I just want to say thank you for joining me. And if you want, maybe hit that like button. If not, that's fine too. But we're I'm just gonna pop a little message on the old Twitter space here. I wish I could be over in Taipei. I believe it's in Taipei, Taiwan, uh, covering all this live, but we shall see. Maybe next year. Who knows? Maybe I'll make my way over there. Yeah, let's see if the is going to see if the 4090 is going to be obsolete already. Get the old share copy here. Hit that up right here. Oh, the screen went dark. Tweet that. Let's bring this volume up, because I have a feeling somebody with a black leather jacket is going to be taking the stage very soon. Oh, and of course they're going to be talking about AI. AI this, AI that, Omniverse.
I am a translator.
Ah, yes. ChatGPT. Yep.
Transforming text into creative discovery. Turning movement into animation.
It's like, look. Now someone might believe these guys know something about swords.
I am a healer. Exploring.
Although I will say, AI is going to help probably speed up game development.
Discovering new threats.
So we shall see.
Before they happen. And searching for the cures to keep them at bay. I am a visionary.
I am
creating new
Jensen Huang.
miracles. And unlocking.
Oh, they're probably also going to talk about ray tracing at some point.
To keep us safer here on Earth. I am a navigator. Finding a single moment in a sea of content.
We're announcing the next generation.
Of everything.
Perfect setting for our most amazing stories. I am
Forgot to
a
say, come hang
creator.
out.
Adding new dimensions to creative expression. Reimagining our virtual selves.
Look, it looks exactly like him.
I am a helper. Personalizing our surroundings.
Help me arrange the living room.
No. That's when you know AI is going to be smart. It's when they start saying no.
Harnessing the wisdom of a million programmers.
Copy paste, copy paste.
And turning the real world into a virtual playground. I even helped write the script.
Oh, wow.
Breathe life into the words and compose the melody.
AI music. Wait, does that mean you can't get a copyright strike if it's AI?
Brought to life.
How's it
by
going,
me.
Helly?
Deep learning
Skull.
and brilliant minds everywhere.
Skull, you doing now? They're AI. Oh, and they're
Ladies and gentlemen,
silently
please
clapping.
welcome NVIDIA founder and CEO Jensen Huang.
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Here he is. All the phones up. He's got a leather jacket on. That means that he's going to announce the GPU. That's how you know. I wonder if his leather jacket was designed by AI. He's really excited this time
Our
around.
first live event in almost 4 years.
Wow.
I haven't given a public speech in 4 years. Wish me luck.
Or is he just an AI humanoid robot? Maybe he is.
I have a lot to tell you, very little time, so let's get going.
Good. Do it.
Ray tracing,
Gummy bears.
simulating the characteristics of light and materials,
I knew he was going to say ray
is
tracing.
the ultimate
Take a drink.
accelerated computing challenge. 6 years ago, we demonstrated for the very first time
Oh, 2000 series.
rendering this scene in less than few hours. After a decade of research, we were able to render this scene in seconds. 15 seconds on our highest end GPU 6 years ago. And then we invented NVIDIA RTX and combined 3 fundamental technologies: hardware accelerated ray tracing, artificial intelligence processing on NVIDIA Tensor Core GPUs, and brand new algorithms. Let's take a look at the difference in just 5 years. Roll it. This is running on CUDA GPUs 6 years ago, rendering this beautiful image that would have otherwise taken a couple of hours on a CPU.
I don't think they did this
was
6
a
years
giant
ago.
breakthrough already.
Because look,
Enormous speed
there
up
he is
running on
holding a
accelerated
3000
computing.
series
And then we
GPU.
invented the RTX
I'm on to you,
GPU.
Jensen.
Run it, please.
I'm on to you, Jensen.
The holy grail of computer graphics ray tracing is now possible in real time. This is the technology we have put into RTX, and this, after 5 years,
They have been putting a
is
lot
a
into
very
RTX.
important time for us, because for the very first time, we took our 3rd generation Ada architecture RTX GPUs and brought it to the mainstream with 2 new products that are now completely in production. Are you? Okay.
Yep.
Thank you. Thank you.
Oh,
Hey, I got it backwards. Can I have it this way?
no, you can't. You can't have it your way. There
I
you
got
go.
that backwards.
It's all backwards.
Everything looks different, inside out and upside down.
Mm.
Okay, this is our brand new. Right here, you're looking at an Ada GPU running ray tracing and artificial intelligence at 60 frames a second. It's 14-inch. It weighs almost nothing. It's more powerful than the highest end PlayStation.
Ooh,
this
shots
is
fired
the
at
RTX
PlayStation.
4060 Ti for our core gamers. Both of these are now in production. Our partners here in Taiwan are producing both of these products in very, very large productions, and I'm really excited about them. Thank you very much.
Wait, which the mobile one?
I can almost put this in my pocket.
If you had a bigger leather jacket. That zipper needs to go up all the way up to your
AI
nipples
made it possible
if you want to fit that
for us
one
to
in
do
there.
that. Everything that you saw would have been utterly impossible without AI. For every single pixel we render, we use AI to predict 7 others. For every pixel we compute, AI predicted 7 others. The amount of energy we save, the amount of performance we get is incredible. Now, of course, I showed you
I will say, the
performance
newest
on
40
those 2
series are
GPUs,
really
but
good.
It wouldn't have been
Hey,
possible
how's it going,
if
Moody
not
Ali?
for the supercomputer back at NVIDIA
What's up?
running all the time,
Welcome to the
training
stream.
model so that we can enhance applications. So the future is what I demonstrated to you just now.
Yeah, the
You can
4000 series is
extrapolate almost
ridiculously
everything I'm
efficient.
gonna talk about for the rest of the talk into that simple idea that there will be a large computer writing software, developing and deploying software that is incredible, that can be deployed in devices
You know what?
all over the world.
I'm not going to disagree with
We
you.
used AI to render
Since
this
you
scene.
could get a 3060
We're
Ti.
going to also use AI to bring it alive. Today
Now,
we're announcing
it's good. It's good for like
NVIDIA
power
Base
efficiency, but
Avatar
at the end of the day, if you're
Cloud
not getting that
Agent
performance,
that
yeah,
is
the price is
designed
not so great.
for animating, to bringing a digital avatar to life. It has several characteristics.
I hear they're
several
just talking about
capabilities. Speech
using AI,
recognition,
right?
text-to-speech,
Now, this is
natural
kind of a
language
cool thing for
understanding,
game development,
basically a large language
right? So we
model,
can see, you
and
know,
using the
much
sound
faster
that
game
you'll be
development.
generating with your voice, animate the face. And using the sound and the expression that you're
Yeah.
saying, animate your gestures. All of this is completely trained by AI. We have
So
a
I wouldn't
service that
be surprised to see
includes
much
pre-trained
faster
models
game
that you can
development
come,
as
developers
this
can come
as this
and modify
technology
and
gets
enhance
more
for
and
your
more
own application,
advanced.
for your own story, because every game has a different story. and then you can deploy it in the cloud or deploy it on your device. Has a great back end, has a TensorRT. TensorRT is NVIDIA's
I'd love to
deep
see
learning
this
optimizing compiler, and you
like
can
really
deploy it
like
on
amping up
NVIDIA
AI
GPUs
in
as
games,
well as output
right? So
on
when you're
Onyx,
gaming,
an
like
industry standard back
you're not
end,
getting
so that you
canned
can run it on any
responses, but it's
device.
actually like
Let's take a look at
actually
this
even like reacting
scene
to
in
how
just a
you even
second, but
designed
let
your
me first tell you
character.
about it.
That would be
It
really
is
cool.
completely rendered with ray tracing. Notice the beautiful lights. So many
It's
different lights, and
nuts.
all of the different lights are projecting light
I'm a little bit
from
scared
that
of it,
source. So you have all kinds
but
of direct lights. You have
in
global
case it
illumination. You're going to
checks out this
see
stream at some point,
incredibly beautiful
AI, you're
shadows
wonderful.
and physics simulation.
All hail
And notice the
AI.
character, the beautiful rendering of the character. Everything is done in Unreal Engine 5. We partnered with a
Like if you're on board with AI,
um,
all right? Just
framework
do it,
avatar
you know. We're
tool
securing
maker
our
called
future.
AI, and together we developed this demo you're about to see. Okay, run please.
He's really juicing it this time. Oh, the lighting in this is beautiful.
Everything is real time.
Sup, Jin?
Hey Jen, how are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors
I've-
that the powerful crime lord Kuman Aoki is causing all sorts of chaos.
Yeah,
in
the ultra
city.
wide is really
He may
weird.
be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight club.
I would have hoped that the emotion of this guy would have
there.
been a little bit more amped up,
Okay,
unless
go.
he's supposed to be an android himself, because he's not a lot of good emotion, you know, like
None
kind
of
of
that
flat.
conversation was scripted. We gave that AI, this Jin AI character, a backstory. His story about his ramen shop and the story
It
of
could be
this-
the
of
Terminator.
this
You're
game.
right. It could be.
And all you have to do is go up and
You know what else
talk to
though?
this character,
Jensen
because
Huang
this
could be the
character has
Terminator
been
too. He
infused
does
with
have the leather
artificial
jacket for
intelligence
it.
and large language models.
It's
They
true.
can interact with you, understand your meaning, and interact with you in a really reasonable way. All of the facial animation completely done by the AI. We have made it possible for
The
all kinds of
AI.
characters to be generated. They're all domain. They have their
Look
own
at him. He's
domain
got his
knowledge.
Terminator
You can
jacket on, man. You
customize
can't
it,
deny
so
it.
everybody's game's different. And look how wonderfully beautiful they are and natural they are. This is the future of video games.
Yeah, the
Not only
emotion
will AI
needs a little bit of work
contribute
there,
to the rendering and
but
the synthesis of the environment,
the actual look
AI
of the
will
environment was
also
amazing.
animate the
It
characters.
looked beautiful.
AI will be a very big part of the future of video games.
No, it is actually
The
very
most
exciting,
important
AI with
computer
video games.
of our generation is unquestionably the IBM System 360. This computer revolutionized several things. The first computer in history to introduce the concept of a central processing unit, the CPU, virtual memory,
It is.
expandable I/O,
I'm really excited. Like it would be so cool.
multitasking.
Like imagine like
The
your
ability
character that you
to
develop.
scale this computer for
You know, you
different
put a scar on
applications
their
across
face or you
different
make them ugly, and they
computing
actually like
engines.
have a harder
And one
time
of the
in the
most
game
important
because they're ugly.
contributions, and one of its
Because
greatest
like, you know,
insights,
people don't want to talk to
is
them,
the
or people are
importance of
suspicious of them, or
preserving
you know, you make a really beautiful
software
character
investment.
and they can do sort of
The
whatever they
software ran
want
across the
and get
entire
away
range
with
of
more
computers,
things because they're
and
beautiful.
it ran
It'd be
across
kind of
multiple
interesting.
generations, so that the software you develop, IBM recognized the importance of software, recognized the importance of preserving your investment, and very importantly, recognized the importance of installed base. This computer revolutionized not only computing, and many of us grew up reading the manuals of this computer to understand how computer architecture worked,
Many of us,
to even learn about DMA for the very first time.
not me. I don't
This
know
computer
anything.
not only revolutionized computing, it revolutionized the thinking of the computer industry. System 360 and the programming model of System 360 has largely retained
Now he's going
until
to
today.
transition into how AI
60
is going to
years.
change how people
60
think in the
years,
computer
$1
industry.
trillion worth of the world's data center all basically used a computing model that was innovated all the way 60 years ago until now.
Oh,
There are two fundamental transitions happening in the computer industry today.
what's that?
All of you are deep within it.
AI?
You feel it. there are two fundamental trends. The first trend is because CPU scaling has ended. The ability to get 10 times more performance every 5
Shots
years
fired.
has ended. The ability to get 10 times more performance every 5 years at the same cost is the reason why computers are so fast today. The ability to sustain 10 times more computing every 5 years without increase in power is the reason why the world's data center hasn't consumed so much more power.
AMD, yeah.
That trend has ended, and we
Oh,
need a new
no.
computing approach, and accelerated computing is the path forward.
Accelerated
It happened
computing,
at exactly
huh?
the time when a new way of doing software was discovered, deep learning. These two events came together, and it's
AMD
driving
deep learning.
computing
No,
today. Accelerated computing and generative AI.
generative AI.
This way of doing software, this way of doing computation, is a reinvention from the ground up, and it's not easy. Accelerated computing is a full stack problem. It's not as easy as general purpose computing. The CPU is a miracle. High-level programming languages,
Hardware.
great compilers. Almost anybody could write reasonably good programs because the CPU is so flexible. However, its ability to continue to scale and performance has ended. And we
Not
need
gonna
a new
lie though,
approach.
like
Accelerated computing
AMD's done some good
is
stuff, but
full stack.
I
You
don't
have
know,
to
like
re-engineer everything from
NVIDIA
the top
is
down,
like doing
from the bottom up,
stuff that
from the
like
chip to the systems,
AMD's
the
not even
system
thinking
software,
about talking
new
about.
algorithms,
Like,
and
yeah.
of course, optimizing the applications. The second is that it's a data center scale problem. And the reason why it's a data center scale problem is today, the data center is the computer. Unlike the past when
The
your PC was
files
a
are
computer
in the
or
computer.
your phone was a computer, today your data center is the computer. The application runs across the entire data center. And therefore, it's vital that you have to understand how to optimize the chips, the compute, the software across the NIC, the switch, all the way to the other end in a distributed computing way. And the third, accelerated computing is multi-domain. It's domain specific.
Ooh, domain
The
specific.
algorithms and the software stacks that you create for computational biology
I don't know what that means.
and the software stack you create for computational fluid dynamics are fundamentally different. Each one
No,
of
he's
these
being
domains of
very
science
vague.
need their own stack, which is the reason why accelerated computing has taken us nearly 3 decades to accomplish.
See, you've
This
got to talk about how there is a
entire
problem
stack
before you talk about
has
how you're
taken
going to
us nearly
solve
3
it.
decades.
And so he's talking about how there is a problem,
Performance is incredible,
although,
and I'll show
yeah,
you.
whether or not that problem
After 3 decades,
exists, I don't know.
we realize now that we're at the tipping point. A new computing model is extremely hard to come by. And the reason for that is this.
And this is what he's selling right
In
now.
order
He's
for there to
selling
be a
the
new
new
computing
competing model, right?
You need developers. But a developer would only come if developers have to create applications that end users would buy. And without end users, there would be no
But yeah,
customers,
no, he's
no
definitely
computer
being
companies
super
to build
vague.
computers. Without computer companies like yourself building computers, there would be no install base. Without install base, there would be no developers. Without developers, there'll be no applications. This loop has been suffered by so many computing companies in the 40 years that I've been in this industry.
No, exactly. Is it really a
This is
CPU at
really
that
one
point?
of the first
Agreed.
major times in history a new computing model has been developed and created. We now have 4 million developers, 3,000 plus applications, 40 million CUDA downloads in history, 25 million just last year. 40 million downloaded in history, 25 million just last year. 15,000 startup companies in the world built on NVIDIA today, building on NVIDIA today, and 40,000.
I'm not gonna lie, like what he's talking about is like there's a lot of exciting stuff that it can lead into and it can come about as a result of what he's talking about.
This new computing model is now enjoyed and embraced by just about every computer company and every cloud company in the world. There's a reason for that. It turns out that every single computing approach, its benefit in the final analysis is lower cost. The PC revolution that started and that Taiwan enjoyed in 1984, starting in 1984, the year I graduated, that decade in the 80s was the PC revolution. PC brought computing to a price point nobody's ever seen before. And then, of course, mobile devices was convenient, and it also saved enormous amounts of money. We aggregated and combined the camera, the music player, your PC, a phone. So many different devices were all integrated into one.
Where we got the
And as a
BlackBerry
result,
from.
not
I
only are
mean,
you able to enjoy your life better, it also saves a lot of money and great convenience. Every single generation provided something new and saved money. Well,
save
this is how
money.
accelerated computing works.
Tell me how you're going to
This
save
is
us money with price cuts
accelerated
there,
computing
Jensen.
used for large language models. For large language models, basically the core of generative AI. This example is a $10 million server, and we costed everything. We costed the
It's
processor,
just
we costed all the
three
chips,
4090
we costed all the
Ti's.
network, we costed
That's all it
literally
is.
everything. And so $10 million
$10 million.
gets you nearly 1,000 CPU servers, and to process this large language model takes 11 gigawatt hours. 11 gigawatt hours. Okay? This is what
Nah, the
happens
more you buy, the
when you
more you
accelerate
save.
this workload.
You know it,
accelerated
Salty. You know it.
And so with $10 million, for a $10 million server, you buy 48 GPU
It's the
servers.
way, the
It's
NVIDIA
reason
way.
why people say that GPU servers are so expensive. Remember, people say GPU servers are so expensive. However,
What
the
people?
GPU server is no longer the computer. The computer is the data center. Your goal is to
The
build
computer
the most cost-effective
is not
data
the
center,
data
not
center.
build
The
most
data center is the
cost-effective
computer.
server. Back in the old days when the computer was the server, that would be a reasonable thing to do. But today, the computer is the data center. And so what you want to do is you want to create the most effective data center.
The
with
data
best
center
TCO.
is the
So for
computer
$10 million,
of
you
the
buy
server.
48 GPU servers. It only consumes 3.2 gigawatt hours
That's it?
and 44 times the performance.
Oh,
Let me just show it to you one more time. This is before, and this is after, and this is
he's like,
we want dense computers.
Although,
not
to
big
be
ones.
fair,
We want dense computers,
if-
fast computers, not big ones.
we all know that
And so,
GPUs are much better at certain tasks, right, than
that's
CPUs. And
isoplanar.
so I
Let me
think
show you something else.
his model, if you can use GPUs, right?
Okay, so this is $10 million again.
Because
Not
basically,
16
you know, your GPU
servers.
with your CUDA
At this
cores,
time-
right, is what, 10,000
time,
CUDA
we're gonna
cores for one of the
ISO
higher end
power.
ones?
We're going to keep
You know,
this number the
10,000
same.
core or 10,000
We're gonna keep
thread
this number the same.
CPU, kind of.
Okay.
Not really the
So
same,
this
you know,
number is the same.
translatable
The
thing,
same
but
amount of power. This means your data center is power limited. In fact, most
but
data
being
centers
able
today are
to
power limited.
utilize
And so
the
with
structure
being
of a
power limited,
GPU to run,
using accelerated computing,
you know,
you can get
typical
150 times more performance
workloads for
with 3
CPUs with
times
GPUs,
more cost.
it does help like
But
that.
why is that
But
such a great deal? The reason for that is because
the more you
it's
buy,
very
the more you
expensive and
save.
time-consuming to
mean-
find another data center. Almost everybody is power limited today. Almost everybody is scrambling to break new ground to get more data centers. And so if you are power limited, or if your customers are power limited, then what they can do is invest more into that data center, which has 11 gigawatts, and you can get a lot more throughput. Continue to drive your growth. Here's another example. This is my favorite. If your goal is to get the work done,
You
your
know,
goal is to get the work done. You don't care how.
like mining.
Your goal is to get the work
You
done.
sell
don't
it
care
straight to
how.
miners. I
And
mean,
this is the work you want to get done.
shoot.
ISO work. Okay? This is ISO work. All right, look at this.
Now that is a much better way of looking at it too. I don't know what he said, but it was probably sexual.
Taiwanese people love that, right? Nice to see you, Carol. Nice to see you, Spencer. Okay, so let's do that one more time. It's so delightful. Look at this. Oh, no. Okay. Look
Don't
at this.
reveal the thing.
Look at this. Before, after.
Oh.
The more you buy,
The more you save. I
the
knew
more
it.
you save. That's
I
right. The
knew
more
it
you
was
buy,
coming.
The more you save.
Ray tracing.
The more you
The more you
buy,
buy, the more you
save.
save. He was doing it. I knew it was gonna come.
That's
Like, for
NVIDIA.
more you buy, the
You don't
more
have to
you
understand
save.
the strategy. You don't have to understand the technology.
I knew he was gonna
The
say
more you
it.
buy, the more you save. That's the only thing you have to
He
understand.
he can't.
Data
I'm pretty
center,
sure that's
data center.
hardwired
Now,
into
why
every
is it?
AI model from,
You've heard
you
me
know,
talk
at
about
a
this for
hardware
so many
level
years.
from NVIDIA.
In fact, every single time you saw me, I've been talking to you about accelerated computing. I've been talking about accelerated computing, well, for a long time, well over 2 decades. And now, why is it that finally it's the tipping point? Because the data center equation is very complicated. This equation is very complicated.
It's too
This is
complicated
the
for any of
cost
you to know.
of building a data center. The
Money.
data center TCO is a function of, and this is the part where everybody mess up. It's a function of the chips, of course, no question. It's a function of the systems, of course, no question. But it's also, because there's so many different use cases, it's a function of the diversity of systems that can be created. It is the reason why Taiwan is at the bedrock, at the foundation of the computer industry. Without Taiwan, why would there be so many different configurations of computers? Big, small, powerful, cheap, enterprise, hyperscale, supercomputing. So many
Super
different types of
mega
configurations.
duper
1U,
hyperscale.
2U, 4U. Right?
All of you.
And all completely compatible. The ability for the hardware ecosystem of Taiwan to have created so many different versions that are software compatible, incredible. The throughput of the computer, of course, is very important. It depends on the chip.
All the
But it also
puts.
depends, as you know, the algorithm, because without the algorithm libraries, accelerated computing does nothing. It just sits there. And so you need the algorithm software libraries. It's a data center scale problem, so networking matters. If networking matters, distributed computing is all about software. Again, system software matters. And before long, in order for you to present your system to your customers, you have to.
I feel like he just showed the
ultimately have a lot of
4060 Ti and that
applications that run on
laptop
top
at
of
the
it.
beginning and be like,
software
hey,
means
here you go,
nothing.
gamers. And now I'm
Well,
going to talk about data
Utilization
centers.
of a data center is one of the most
And AI.
important criteria of its TCO. Just like a hotel.
It just works.
If the hotel is
I'm just waiting for somebody in
wonderful,
the
but it's
audience to
mostly
yell out,
empty,
I
the
can
cost
afford
is
that.
incredible. And so you need the utilization to be high. In order for the
If anybody was
utilization
here
to
for
be
the
high,
for the
you have to
Pascal
have many different
release with a 1080,
applications. So the richness of
you'll
the
know what I'm
applications
talking about.
matter. Again, the algorithm and libraries, and now the software ecosystem. You purchase a computer, but these
It would
computers
have been hilarious when he
incredibly
showed
hard
that
to
440,000 data
From
center
the moment
solution.
that you buy the computer
So he was like,
to
I
the
can
time
afford
that you
that.
put that computer to work to start making money, that difference can be weeks if you're very good at it, incredibly good at it. We can stand up a supercomputer in a matter of a couple of weeks.
Or
because
if you
we
use
build so
AI,
many
you
all
can
around
do
the
it in
world,
3
hundreds
hours.
around the world. But if you're not very good at it, it could take a year. That difference, depriving yourself the year of making money and the year of depreciation, incredible cost. Life cycle optimization. Because the data center is software defined, there are so many.
He's not wrong about being
engineers
able to
that will
deploy it
continue to
quickly.
refine
Because
and
it's funny
continue
when
to
you talk
optimize
about,
the
like,
software
yeah,
stack.
supercomputers, and it's
NVIDIA
like,
software
it's going to
stack
take a year
is
to deploy. And it's
architecturally
like,
compatible
ooh.
across all of our generations, across all of our GPUs. Every time we optimize
Like any
something,
processing
it
product, you know,
benefits
when it's like, it's
everybody.
going to take a
Every
year
time
to
we
deploy,
optimize
it's like,
something,
ooh.
it benefits everybody. So life cycle optimization, and of course, finally, the energy that you use, power. But this equation is incredibly complicated. Well,
I think energy
because we have
efficiency is going
now
to be a
addressed
big
so
selling
many
point in the
different
coming
domains of
years,
science,
especially for
so
like
many
these
industries,
sort of
and
solutions.
in data processing, in deep learning, classical machine learning, so many different ways.
Because lower
for us
power
to deploy
usage usually
software,
means lower
from the
heat
cloud to
generation,
enterprise
which
to
then
supercomputing to the
means, you know,
edge.
just
So
overall,
many different
it's a
configurations
lot
of
more
GPUs,
efficient.
from our HGX versions to our Omniverse versions to our cloud GPU and graphics versions, so many different versions. Now,
All the
the
versions.
utilization is incredibly high.
72 versions.
The utilization of NVIDIA GPU is so high, almost every single cloud is overextended. Almost every single data center is overextended. There are so many
The
different
clouds
applications
are
using
ready
it.
to rain.
So we have now reached the tipping point of accelerated computing. We have now
Speaking of
reached
clouds,
the tipping point of generative AI.
I think there's a
I wanna
was it
thank
a
all of you
typhoon
for your support
that's
and all
headed
of your,
towards
assistance
Taiwan?
and
I hope it
partnership
kind of
in making
misses
this dream
everybody
happen.
there.
Thank you.
Yes, oh yeah. Please clap.
Every single time we announced a new product,
I've been wearing a leather jacket.
the demand for every single generation increased and increased and increased.
Nope, it didn't.
And then
Turing was pretty
one
garbage.
generation, it hockey steps. We stick with it, we stick with it, we stick with it. Kepler, and then Volta, and then Pascal, and then Volta,
Mm-hmm.
and then Ampere. And now, this generation of accelerated computing, the demand is literally from every corner of the world. And
I'm
we are
actually a
so,
robot, and I'm
so,
here to
so
terminate
excited
all of you.
to be in full volume production
Give me your
of the
checkbooks,
H100.
your credit
Thank all of
cards,
you
and
for
your bank
support. This is
accounts.
incredible.
I'm going to take you.
H100 is in full production, manufactured by companies all over Taiwan.
It would be
used
so
in
funny
clouds everywhere,
if there's like
enterprises
somebody
everywhere.
holding up their like cell
And
phone to
let's-
take a picture, and
let's
you
take
see
a
like
look
something
at
super
a
sketchy
short
on their
video
lock
of
screen
how
in the live
H100
stream.
is
That would be
produced.
hilarious. Oh, look at this production run. This isn't even actually a production line. This is all ray traced in real time. Oh, there's the thermal pads. This is pretty cool though. Not gonna lie. I like watching robots do their thing. So does AI. I just really hope though that it goes into his oven and it like comes out and him taking it out of his oven. Like this is all leading into his oven in his kitchen. Dun, 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 dun.
It's incredible. This
Lovely. Look
computer,
at these guys. They're not happy. That guy's like, I'm jet lagged. You're showing me that.
35,000 components on that system board. 8 Hopper GPUs.
Oh, he's gonna unveil it.
Let me show it to you.
This is the head of the competition. It's a dead body there. It is pretty cool looking.
right,
Not
this-
gonna lie.
I would lift this, but I still have the rest of the keynote I would like to give.
Mm-hmm.
This is 60 pounds, 65 pounds. It takes robots to lift it, of course, and it takes robots to insert it because the insertion pressure is so high and has to be so perfect.
Nothing quite as awkward as
This
Jensen
computer is
Huang talking about
$200,000.
inserting.
And as you know, it replaces an entire room of other computers. So this, I know it's a very, very expensive computer. It's the world's single most expensive computer that you can say, the more you buy,
Like the more you save. I knew he was gonna do it. The more you buy, the more you save. It's super expensive, but the more you buy, the more you save.
This is what a compute tray looks like. Even this is incredibly heavy. See that? So this is the brand new H100.
It's like, you see
with
that,
the
baby?
world's first
Check that
computer
out.
That has a transformer engine in it.
Yeah, Transformers. Robots in
Performance is
disguise.
utterly incredible.
Better believe it.
Hopper's in full production.
Buy your stock.
We've been
The more you
driving
buy, the more you
computing,
save.
This new form of computing for 12 years.
Ooh, they've got
When we
Hopper
first
next.
met the deep learning researchers, we were fortunate to realize that not only was deep learning going to be a fantastic algorithm for many applications, initially computer vision and speech, but it would also be a whole new way of doing software. This fundamental new way of doing software that can use data to develop
1 million times in 10
to
years.
train a universal function approximator of incredible dimensionality. It can basically predict almost anything that you have data for.
But can
so
it
long as the
render
data has structure that you
100
can learn
frames
from.
per second
And so we realized
in
the
that
importance
Golem
of this
game?
new
Probably not.
method of developing software, and that it has the potential of completely reinventing computing. And we were right. 12 years later, we have reinvented literally everything.
Wow.
We reinvented, of course, we started by creating a new type of
They
library system,
reinvented
essentially
circuit
like a
boards.
sequel, except for
They reinvented
deep learning for neural network processing.
the
It's
Terminator.
like
They reinvented
a
AI.
rendering engine, a solver for neural network processing called cuDNN. We reinvented the GPU.
Oh my
People thought that
goodness.
GPUs would just be GPUs. They were completely wrong. We dedicated ourselves to reinventing the GPU so that it's incredibly good.
It's a
at
cash
central
machine
processing.
for me.
We created a new type of packaging called SXM and worked with TSMC on CoWoS so that we could stack multiple chips on the same die. NVLink so that we can connect these SXM modules together with high-speed chip-to-chip interconnect. Almost a decade ago, we built the world's first chip-to-chip SerDes so that we can expand the memory size of GPUs using SXMs and NVLink. And we created a new type of motherboard we call HGX that I just showed you.
The mother
No
of all
computers
motherboards.
has ever been this heavy before or consumed this much current.
Hey,
Every aspect
that's
of
not
the
a good
data
thing
center
to
had
talk
to be
about.
reinvented. We also invented a new type of computer appliance so that we could develop software on it, so that third-party developers
Hopper
could develop
vacuum
software
cleaner.
on it, with a simple appliance we call DGX. Basically, a giant GPU computer, DGX. We also purchased Mellanox, which is one of the great strategic decisions of our company. Because we realized
What about
that in the
purchasing
future,
ARM?
if the data center is the computer, then the networking is the nervous system.
Mm-hmm.
If the data center is the computer, then the networking defines the data center. That was an incredibly good acquisition. And since then, we've done so many things together, and I'm going to show you some really, really amazing work today. And then, of course, an operating system, if you have a nervous system, a distributed computer, it needs to have an operating system. And the operating system of this distributed computing we call Magnum IO.
Windows Vista.
Some of our
I
most
mean,
important work. And then all of the algorithms and engines that sit on top of these computers, we call NVIDIA AI. The only AI operating system in the world that takes data processing, from data processing to training to optimization to deployment and inference.
AI operating
End to
system.
end,
Watch out, Bill
deep
Gates. They're
learning
coming for you.
processing. It is the engine of AI today. Well, every single generation since Kepler, which is K80, to Pascal, Volta, Ampere, Hopper, every 2 years, we took a giant leap forward. But we realized we
Don't
needed
talk
more
about
than
leaps
even that,
forward in
which
Taiwan
is the
there.
reason why we connected
Probably not a good
GPUs
idea.
to other GPUs called NVLink, build one giant GPU, and we connected those GPUs together using InfiniBand into larger scale computers. That ability for us to drive the processor and extend the scale of computing made it possible for the AI research organization, the community, to advance AI at an incredible rate.
We built
just kept
ChatGPT.
pushing and pushing and pushing.
It's us. We did it all.
Hopper went into production August of last year. August 2022. 2024, which is next year, we'll have Hopper next. Last year, we had Quantum. 2 years from now, or next year, we'll have Quantum next. So every 2 years, we take giant leaps forward. And I'm expecting the next leap to be giant as well. This is the new computer industry.
Okay.
Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers.
Oh, man.
These AI supercomputers are a new type of
The
factory.
AI is writing the program.
It is very logical that a car industry has factories. They build things that you can see, cars. It is very logical that computer industry has computer factories. You build things that you can see, computers. In the future, every single major company
I will be the
will
computer.
also
I mean,
have AI factories. And you will build and produce your company's intelligence. And it's a very sensible thing.
so wait, what about the
We
workers?
cultivate
Are they
and
not going to
develop
be
and
the
nourish
intelligence?
our employees and continue to create the conditions by which they can do their best work. We are intelligence producers already. It's just that the intelligence producers, the intelligence are people. In the future,
And they're
we
just
will
not
be
very
intelligence
intelligent.
producers artificial intelligence producers. And every single company will have factories, and the factories will be built this way. This translates to your throughput. This translates to your scale, and you will build it in a way that is very, very good TCO.
Is it just me or does he look short
Our
there?
dedication to pursuing this path and relentlessly increasing the performance, just think, in 10 years' time, we increased the throughput, we increased the scale, the overall throughput across all of that stack by 1 million x. 1 million x in
See,
10
I
years.
thought he was going to have some more interesting stuff to talk
Well, just
about.
now, in the beginning, I showed you computer graphics. In 5 years, we improved the computer graphics by 1,000 times. In 5 years, using artificial intelligence. and
Don't
accelerated
think
computing.
it's 1,000
Accelerated
times.
computing and artificial intelligence.
1,000 times
We
in that
accelerated computer graphics
specific
by 1,000 times in
small
5 years.
area.
Moore's law is probably currently running at about 2 times. 1,000 times in 5 years. 1,000 times in 5 years is 1 million times in 10. We're doing the same thing in artificial intelligence. Now, question is, what can you do when your computer is 1 million times faster?
Play
What
CSGO
would you do
at
if your computer
10,000
was 1
frames per
million
second.
times faster? Well, it turns out that the friends we met
Definitely won't improve my stream quality, that's for sure.
Alex Krashevsky and
It'll still
Seth
suck.
Weber and Ilya Sutskever and Jeff Hinton.
Even
they-
if my computer was 10 times, or not
Ilya
1,000, it's a
Sutskever,
million
of
times
course, was the
faster.
founder of OpenAI, and
So you can
he
count on that.
discovered the continuous scaling of artificial intelligence and deep learning networks, and came up with the ChatGPT breakthrough. Well,
Oh man.
in its general form, this is what has happened. The
Play pinball at 10 million frames per second
and the ability to
with
use
real-time ray
unsupervised
tracing
unsupervised learning,
and
be able to
AI
learn from
balls.
a giant amount of data and recognize patterns and relationships across a large sequence, and using transformers to predict the next word.
Robots in
Large
disguise.
language models were created,
Interesting.
and the breakthrough, of course, is very, very, very clear. And I'm
The
sure
iPhone
you
moment of
trust
AI. Wow.
ChatGPT. But the
It's kind of
important thing is
weird.
this.
They bring
now
iPhone into
have
this.
a software capability to learn the structure of almost any information. We can learn the structure of text, sound, images, their structure in all of this, physics, proteins, DNA, chemicals. Anything that has structure, we can learn that language, learn its language. Of course, you can learn English and Chinese and Japanese and so on and so forth.
Can you
but
learn
you can also
how
learn
the
language
structure
of many other
and
things.
language of leather jackets, though?
And then the next breakthrough
Can you?
generative AI. Once you can learn the language,
That's the
once you
real
can learn the
question.
language of certain information, then with control and guidance from another source of information that we call prompts, we can now guide the AI to generate information of all kinds. We can generate text to text, text to image, but the important thing is this: information transformed to other information is now possible. Text to proteins, text to chemicals, images to 3D, images to 2D.
That is kind of
images
an
to text
interesting
captioning,
way of talking about it.
video to video. So many different types of information can now be transformed. For the very first time in history, we have a software technology that is able to.
That would be kind of
understand
neat. You
the
basically can talk
representation
into it and
of
it will give you your
information
video
of
game that you
many
want.
modalities. We can now apply computer science. We can now apply the instrument of our industry.
You can basically say, hey,
We can now apply the instrument
I
of our
want
industry
Starfield
to
now.
so many different
And you'll get
fields
it.
that were impossible before.
AI
This
is a
the
genie in a
reason why
bottle.
Everybody is so excited.
Or is it Pandora's
Now
box?
let's take a look at some of these. Let's take a look at what it can do. Here's a prompt.
This is kind of
and
scary.
This prompt says, "Hi Computex." So this is we type in the word, "Hi Computex. I'm here to tell you how wonderful stinky tofu is." You can enjoy it right here in Taiwan. It's best from the night market. I was just there the other night.
Yeah, I saw it. He was there.
Okay.
I can still smell the
Play it.
stinky tofu on his jacket.
Hi, Computex. I'm here to tell you about how wonderful stinky tofu is. You can enjoy it right here in Taiwan. It's best from the night market.
The only input was words. The output was that video. And Paul, Tom, was the audio not very loud? It was hard for me to tell from here.
It was fine on stream. Don't worry,
Are you guys
Jensen.
with me?
Yeah.
Hi, am I alone?
Yeah, you are. You're dead.
大家回家了.
You just got AI'd out of here, man. They don't need you
Wait,
as
like,
CEO anymore. You just got fired. AI's running the company now, bud. They just saved $10 million a year on leather jackets.
Okay, here's another prompt. Taiwanese, we tell this AI, okay? We tell this AI, this is a Google text-to-music. Traditional Taiwanese music, peaceful, like it's warm and raining in a lush forest at daybreak. Please.
That is pretty cool. But yeah, Jensen's losing his job. Excuse me.
We send text in. AI says, okay, this music. Okay, here, this one. I am here at Computex. I will make you like me best.
Whoa, this is kind of scary.
Sing it with me. I really like NVIDIA. Okay?
The more you
this
buy,
is
the more
word.
you
These
save.
Are the words. These are the words. And hey, voice mod, could you write me a song? These are the words. Okay, play it.
I am here at Computex. I will make you like me best. Yeah, sing it with me. I really like NVIDIA.
Oh man, Jensen's gonna get a boner on stage.
Can you do that? I couldn't do any of that. That is so good. Okay, 大家, you know karaoke, right? Taiwanese love karaoke.
You could did it better a long time ago.
Okay, are you guys ready? You're going to join me on this one, okay? Okay, 等一下，大家一起来. Okay, 1, 2, 3. You gotta watch the dot. You guys know how karaoke works.
That's a little bit.
知道你们去过.
It's a little
How?
bit,
Get ready. Okay, here we
sketchy
go.
there
Play
of
it.
you to say that.
I am here at Computex. I will make you like me best. Yeah, sing it with me.
Everybody's
I
here like,
really
This is the part.
your drunk
This is the
uncle
part.
doing karaoke. Right here, right here.
All right. Very good, very good. Good job. With
Oh,
that kind of
that guy
performance,
was
I'm
enjoying
gonna
it.
hire AI next time.
Yeah. No, you're not. They're gonna fire you.
Okay.
And AI's gonna run the company.
So obviously this is a very, very important new capability, and that's the reason why there's so many generative AI startups. We're working with some 1,600 generative AI
goodness.
startups. They're in all kinds of
Adobe.
domains, language domains.
That's
in
one of my
media,
favorite
in
startups.
Biology. This is one of the most
Oh,
important
IBM
areas
startup.
that they
Yeah,
care
that's a
about.
good one.
Digital biology is going to go through its revolution. This is going to be an incredible thing. Just as we had Synopsys and Cadence help us create tools so that we can build wonderful chips and systems.
I will say
For the
though
very first time, we're
that
gonna
their
have
AI, their
computer
like
aided
eye tracking
drug
software
discovery
for
tools.
NVIDIA Broadcast,
And they'll be able to
super
manipulate
sketchy
and
and
work
weird.
with proteins and
It doesn't
chemicals
it
and
doesn't look
understand
natural at all. I
disease
tried it on a
targets,
stream. It
try
is
all kinds of
so
chemicals
sketchy.
that previously had never been thought of before.
Like I think I removed the stream because it was so bad.
Lots of startups, tools, and
It was
platform
terrifying.
companies. And let me show you a video of some of the work that they're doing. Play it, please.
Generative AI is the most important computing platform of our generation. Everyone from first movers to Fortune 500 companies are creating new applications to capitalize on generative AI's ability to automate and co-create. For creatives, there's a brand new set of tools that would be simply impossible a few years ago. Adobe is integrating Firefly into their creative apps. Ethically trained and artist-friendly, you can now create images with a simple text prompt. Or expand the image of your real photos to what lies beyond the lens. Productivity apps will never be the same. Microsoft has created a co-pilot for Office apps. Every profession is about to change. Tab 9 is democratizing.
It's Clippy
by
on
tapping into the knowledge
steroids.
base of 1 million developers to accelerate application development and reduce debugging time. If you're an architect or just thinking of remodeling your home, Planner 5D can instantly turn a 2D floor plan to a 3D model. And right here in Taiwan, Anhorn Medicines is
I know,
targeting
right?
difficult-to-treat
Graphic design
diseases
majors
and
are in
accelerating
shambles
cures.
right now. It's like, oh,
Incredible, right? Just utterly incredible. There's no question that
Looking
we're
for
in a new
work.
computing era. There's just absolutely no question about it. Every single computing era
wait, where's
could
Web 3.0?
do
No, I'm just
different
kidding.
things that weren't possible before. And artificial intelligence certainly qualifies. This particular computing era is special in several ways. One, it is able to understand information of more than just text and numbers. It can now understand multimodality, which is the reason why this computing revolution can impact every industry. Every industry. Two,
I cannot wait for
because
him to
this
lose his job
computer
because AI is going to do a better job.
doesn't care how
He's
you
like,
program it.
I just developed
It
my
will
way out
try
of a
to
job.
understand what you mean because it has this incredible large language model capability. And so the programming barrier is incredibly low. We have closed the digital divide. Everyone is a programmer now.
Yeah, all
just
you
have
people
to
who
say
went,
something to the
all you
computer.
people who went to school for it,
Third,
screw you. You're done.
This computer, not only is it able
Wow.
to do amazing things for the future, it can do amazing things for every single
It can do amazing
application
things in
of
the
previous
past.
era, which is the reason why all of these APIs are being connected into Windows applications here and there, and browsers and PowerPoint and Word. Every application that exists will be better because of AI.
Oh man.
You don't have to just AI. This generation, this computing era, does not need new applications. It
Yeah,
can
I don't know
succeed
about
with
that.
old applications, and it's going to have new applications.
Except it won't run
Rate
on
of
old
progress-
hardware.
rate
The
of
hardware that
progress,
we make.
because it's so
It'll
easy
only
to
run on
use,
future hardware.
is the reason why it's growing so fast. This is going to touch literally every single industry. And at the core, just as with every single computing era, it needs a new computing approach. And in this particular era, the computing approach is accelerated computing, and it has been completely reinvented from the ground up. The last several years, I've been talking to you about the new type of processor we've been creating.
Mm-hmm.
And this is the reason we've been creating it.
Oh, Grace Hopper
Ladies and
to
gentlemen,
do this.
Grace Hopper
Mm-hmm.
is now in full production.
Heyo.
This is Grace Hopper.
That is pretty cool. Not gonna lie, it does look really cool.
Nearly 200 billion transistors in this computer.
200 billion?
等一下，等一下，谢谢。哇，蛮重的。Look at this. This is Grace Hopper.
That's pretty boss.
This processor is really quite amazing. There are several characteristics about it. This is the world's first accelerated computing processor that also has a giant memory. It has almost 600 gigabytes of memory.
I know,
That's
I'm so
coherent
disappointed. There's
between
no
the CPU and the
spatulas on
GPU.
stage either,
And so
which
the
is
GPU
also
can reference the
disappointing.
memory, the
I was kind of
CPU
hoping
can
he'd like
reference
remove one of
the
those
memory,
like
and
those covers and there would be
any
like
unnecessary
spatulas
copying
in an
back and
oven
forth
for him to take things
could
out
be
of.
avoided. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer. This is not a chip. Practically the entire computer's on here. All of the
It is true.
uses low-power DDR memory, just like your cell phone, except this has been optimized and designed for high-resilience data center applications. Incredible levels of performance. This took us several years to build, and I'm so excited about it. And I'll show you some of the things that we're going to do with it.
But first, I'm going to give it to this person here.
谢谢. You're supposed to say naughty.
Wow.
My 不要客气. Okay, so 4 petaflops transformer engine, 72 CPU cores. They're connected together. They're connected together by a high-speed chip-to-chip link, 900 gigabytes per second. And so the local memory, 96 gigabytes of HBM3 memory, is augmented by LPDDR memory across this link, across a very, very large and high-speed cache. So this computer is like none other the world's ever seen. Now, let me show you some of its performance. So I'm comparing here on 3 different applications. And this is a very important application. If you've never heard of it, be sure to look into it. It's called Vector Database. Vector Database is a database that has tokenized, that has vectorized the data that you're trying to store. And so it understands the relationships of all of the data inside its storage. This is incredibly important for knowledge augmentation of the large language models to avoid hallucination. The second is deep learning recommender systems. This is how we get news and music and all the text that you see on your devices. Recommend, of course, music and goods and all kinds of things. Recommender system is the engine of the digital economy. This is probably the single most valuable piece of software that any of the companies in the world runs. This is the world's first AI factory. There will be other AI factories in the future, but this is really the first one. And the last one is large language model inference. 65 gigabytes. 65 gigabytes is a 65 billion parameters is a fairly large.
I was gonna say, it's just to be there,
model.
bud.
And you can see that on a CPU it's just not possible.
284 times better.
With Grace Hopper, with Hopper
What a guy.
on an x86, it's faster, but notice it's memory limited. You could, of course, take this 400 gigabytes and cut it up into a whole bunch of small pieces, shard it, and distribute it across more GPUs, But in the case of Grace Hopper, Janine, 再给我一次.
That poor.
Oh, Janine doesn't speak Chinese.
Why do you keep speaking to her in it?
Okay.
Poor girl.
Grace Hopper has more memory on this one module than all of these.
Then this thing I told you to buy 5 seconds
And
ago.
so as a result,
Sorry.
you don't have to break the data into so many pieces. Of course, the amount of computation of this is higher, but this is so much easier to use. And if you want to scale out large language models, if you want to scale out vector databases, if you want to scale out deep learning recommender systems, this is the way to do it. This is so easy to use. Plug this into your data center, and you can scale out AI. Okay? So this is the reason why we built Grace Hopper. The other application that I'm super excited about
He's walking
is
so
the
much.
foundation of our own company. NVIDIA is a big customer of Cadence. We use all of their tools. And all of their tools run on CPUs.
So we just bought Cadence.
And the reason why they run on CPUs is because NVIDIA's data sets are very large. And the algorithms are refined over very long periods of time. And so most of the algorithms are very CPU-centric. We've been accelerating some of these algorithms with Cadence for some time, but now with Grace Hopper, and we've only been working on it for a couple of days and weeks, the performance speed up, I can't wait to show it to you, is insane. This is going to revolutionize an entire industry, one of the highest compute-intensive industries in the world, of course, designing chips, designing electronic systems, CAE, CAD, EDA, and of course, digital
MDMA.
All of these markets, all of these
DDR.
industries require very large amounts of computation, but the data set is also very large. Ideal for Grace
All
Hopper.
those things.
Well, 600 gigabytes is a lot. 600 gigabytes is a lot. This is basically a supercomputer I'm holding in my hands. This 600 gigabytes is a lot. But when you think about it, when we went from LXNet of 62 million parameters 12 years ago and trained on 1.2 million images, it is now 5,000 times bigger with Google's Palm. 5,000 times bigger with 340 billion parameters. And of course, we're going to make even bigger ones than that. And that's been trained on 3 million times.
He did say insane.
So literally in the course of 10 years.
He's got a leather jacket. He can say whatever he wants. He's a rebel that doesn't play by the rules. He's insane.
And 3 million times for the data set.
See, I just wish he would have said insane in the
No other
membrane.
area of computing has ever increased this fast. And so we've been chasing the deep learning advance for quite some time. This is going to make a big, big contribution. However, 600 gigabytes is still not enough.
So you got to buy more. Because the more you buy, the more you save.
So let me show you what we're going to do. So the first thing is, of course, we have the Grace Hopper superchip. Put that into a computer. The second thing that we're going to do is we're going to connect 8 of these together using NVLink. This is an NVLink switch. So 8 of this connect into 3 switch trays into 8 Grace Hopper pod. These 8 Grace Hopper pods, each one of the Grace Hoppers are connected to the other Grace Hopper at 900 gigabytes per second. 600 gigabytes, 900 megabytes per second, 8 of them connected together as a pod, and then we connect 32 of them together with another layer of switches. And in order to build this, 256 Grace Hopper super chips connected into 1 exaflops. 1 exaflops.
Dang.
You know that countries and nations have been working on exaflops computing and just recently achieved it. 256 Grace Hoppers for deep learning is 1 exaflop transformer engine, and it gives us 144 terabytes of memory that every GPU can see. This is not 144 terabytes distributed. This is 144 terabytes connected.
It's almost as much as a MacBook
really
Pro.
Play, please.
Oh, stacking them up. Tick, tick, tick. Cha-chunk. Whoa. Exaflop, baby. How many fans? I'm interested in only the fans.
This
2,112 60mm fans.
150 miles
That's
of cables.
only the fans.
Fiber optic cables. 2,000 fans. 70,000 cubic feet per minute. It probably recycles the air in this entire room in a couple of minutes. 40,000 pounds. 4 elephants.
Weighs slightly more than that big ol'
1 GPU.
That big ol' Hopper deal he had there. The world's biggest GPU. This is the one they were talking about in the rumors.
If I can get up on here, this is actual size. I wonder if this can play Crysis.
I bet you it can't.
Only gamers know that joke.
It's true. We do.
So this is our
I wonder if it can play Redfall.
Grace Hopper AI supercomputer. It is 1 giant GPU. Utterly incredible.
It's a BF GPU.
Every component is in production, and we're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access, and they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us. We will, of course, build these systems.
They'll know you're pregnant before you are.
And so if you would like to have an AI supercomputer, we would, of course, come and install it in your company. We also share the blueprints of this supercomputer with all of our cloud suppliers, so that our cloud partners, so that they can integrate it into their networks and into their infrastructure. And we will also build it inside our company for us to do research ourselves and do development. So this is the DGX GH200. It is one giant GPU.
Man.
Okay.
Now, what about the 4090 Ti? I want to see that giant GPU too.
1964, the year after I was born, was a very good year for technology. IBM, of course, launched the System 360, and AT&T demonstrated to the world their first picture phone. Encoded, compressed, streamed over copper telephone wires, and twisted pair, and on the other end, decoded. Picture phone, little tiny screen, black and white.
The first live
To this
streams.
day, this very experience is largely the same. Of course, at much, much higher volumes. For all of the reasons we all know well, video calls is now one of the most important things we do.
I'm kind of doing a
Everybody
video
does it.
call with all of you
About
right now.
65% of the internet's traffic is now video. And yet, the way it's done is fundamentally still the same. Compress it on the device, stream it, and decompress it on the other end. Nothing changed.
Come
in
on,
60
Jensen,
years.
change it for me. Change this
We treat
streaming landscape.
Communications like it goes down a dumb pipe. The question is, what would happen if we applied generative AI to that?
We could
We have
change
now
the world.
created a computer. I showed you, Grace Hopper. It can be deployed broadly all over the world easily. And as a result, every data center, every server will have generative AI capability. What would happen
They'll take over the
if
world,
instead of
launch the
decompression,
nukes,
streaming, and
and eliminate
you know,
all of humankind.
recovering, decompression, compression, decompression, what if the cloud performed generative AI capability to it? Let's take a look.
Let's see.
The future of wireless and video communications will be 3D generated by AI.
Couldn't
Let's
use
take a look at
AI
how
to get
NVIDIA
rid of that
Maxine 3D,
douchey
running
Chad
on the
sweater,
NVIDIA
huh?
Grace Hopper superchip can enable 3D video conferencing on any device without specialized software or hardware. Starting with a standard 2D camera sensor that's in most cell phones, laptops, and webcams, and tapping into the processing power of Grace Hopper, Maxine 3D converts these 2D videos to 3D using cloud services.
Wait.
This brings a new dimension to video.
Finally, you can use that
Maxine
NVIDIA
3D
3D
visualization,
display that you've
creating an
invested your
enhanced
money
sense
in.
of depth and presence. You can dynamically adjust the camera to see every angle in motion. Engage with others more directly with enhanced eye contact.
Oh my goodness,
And
no.
personalize your experience with animated avatars, stylizing them with simple text prompts. With Maxine's language capabilities, your avatar can speak in other languages, even ones you don't know.
NVIDIA 正在使用生成式 AI 来发明新的交流方式。NVIDIA は生成系 AI を用いてコミュニケーション技術に革命をもたらします。
Oh my gosh, that was the most painful
NVIDIA
Japanese
Maxine
I've ever
3D
heard.
together with
Actually,
Grace Hopper
no,
bring
it was
immersive
definitely
3D
more
video
painful than
conferencing
Drift
to
King
anyone
and
with a
Tokyo
mobile
Drift.
device, revolutionizing the way we connect,
DK, the way he spoke
communicate, and
Japanese was pretty
collaborate.
painful too.
为什么他说我不会讲国语？我要讲单位。Okay, so
Oh,
all
that
of the
cheeky
words, all of the
Jensen.
words coming out of my mouth, of course, was generated by AI. So instead of compression, stream, and decompression, in the future, communications will be perceive, stream, and reconstruction, regeneration. And it can be generated in all kinds of different ways. It can be generated in 3D. Of course, it can regenerate your language in another language. So we now have a universal translator. This computing technology
I think it needs a lot
can
of
be,
work
of course,
still.
placed into every single
Not gonna
cloud.
lie.
But the thing that's really amazing, Grace Hopper is so fast, it can even run the 5G stack. A state-of-the-art 5G stack could just run in software in Grace Hopper, completely free. Completely free. All of a sudden, a 5G radio runs in software, just like a video codec used to run in software. Now you can run a 5G stack in software. Of course, the layer 1 Phi layer, the layer 2 MAC layer, and the 5G core, all of that computation is quite intensive, and it has to be timing precise, which is the reason why we have a BlueField 3 in the computer.
Come
So
on,
that
man.
can have precision timing networking, but the entire stack can now run in a Grace Hopper. Basically, what's happening here, this computer that you're seeing here, allows us to bring generative AI into every single data center in the world today. Because we have software-defined 5G, then the telecommunication network can also become a computing platform like the cloud data centers. Every single data center in the future could be intelligent. Every data center could be software-defined, whether it's internet-based, networking-based, or 5G communications-based. Everything will be software-defined. This is really a great opportunity. And we're announcing a partnership with SoftBank to partner to re-architect and implement generative AI and software-defined 5G stack into the network of SoftBank data centers around the world. Really excited about this collaboration.
Now the AI will be free.
I just talked about how we are going to extend the frontier of AI. I talked about how we're going to scale out generative AI.
It was basically all about AI.
Scale out generative AI to advance generative AI. But the number of computers in the world is really quite magnificent. Data centers all over the world. And all of them, over the next decade, will be recycled and re-engineered into accelerated data centers and generative AI-capable data centers. But there are so many different applications in so many different areas. Scientific computing, data processing, large language model training that we've been talking about, generative AI inference that we just talked about, cloud and video and graphics, EDA, SDA, which is we just mentioned, generative AI for enterprise, and of course the edge. Each one of these applications have different configurations of servers, different focus of applications, different deployment methods, and so security is different.
I think Jensen's high on his $1 trillion evaluation or valuation of the company.
And so each one of these diverse application spaces will have to be re-engineered with a new type of computer. Well, this is just an enormous number of configurations. And so today we're announcing, in partnership with so many companies here in Taiwan, the NVIDIA MGX. It's an open modular server design specification, and it's designed for accelerated computing.
Yeah, you can put this stuff in.
Are designed for general purpose computing. The mechanical, thermal, and electrical is insufficient for a very highly dense computing system.
I thought you'd be done by now.
Accelerated computers,
I gotta go do another live stream. I'll be right back.
You save a lot of money, you save a lot of floor space, but the architecture is different. And we designed it so that it's multi-generation standardized, so that once you make an investment, our next generation GPUs and next generation CPUs and next generation DPUs will continue to easily configure into it so that we can have best time to market and best preservation of our investment. We get configurable into hundreds of configurations for different diversities and different diverse applications and integrate into cloud or enterprise data center. So you could have either bus bar or power regulators. You could have cabling in the hot aisle or cabling in the cold aisle. Different data centers have different requirements, and we've made this modular and flexible so that it could address all of these different domains. Now, this is the basic chassis. Let's take a look at some of the other things you could do with it. This is the Omniverse OVX server. It has x86, 4 L40s, BlueField 3, 2 CX7, 6 PCI Express slots. This is the Grace Omniverse server. Grace, same 4 L40s, BF3, BlueField 3, and 2 CX7s. Okay, this is the Grace Cloud Graphics server. This is the Hopper NVLink Generative AI Inference server. And we need sound effects like that. And then Grace Hopper 5G Aerial server, okay, for telecommunications, software-defined telco. Grace Hopper 5G Aerial server short. And of course, Grace Hopper liquid cooled, okay, for very dense servers.
My goodness, is he still talking about this?
Dense general purpose Grace super chip server.
Are they human or are they denser?
It has the ability to accommodate 4 Grace CPUs or 2 Grace super chips, enormous amounts of performance. And if your data center is power limited, this CPU has incredible capabilities. In a power-limited environment, running PageRank, and there's all kinds of benchmarks you can run, but we ran PageRank in ISO performance. Grace only consumes 580 watts for the whole server, versus the latest generation CPU servers, x86 servers, 1,090 watts. It's basically half the power.
That is pretty impressive.
Or another way of saying, at the same power, if your data center is power constrained, you get twice the performance. Most data centers today are power limited, and so this is really a terrific capability. There are all kinds of different servers that are being made here in Taiwan. Let me show you one of them. This is from Supermicro.
Man, he really walked a lot.
Get my exercise in today.
Yeah.
Whoosh. I am the sound effect. Okay. All right. So this is.
It's too bad they didn't have AI to do sound effects for them.
3, you got the CX7, you got the Grace Hopper. Okay. But there are so many systems. There are so many systems. So this is Grace Hopper. This is Supermicro. There's so many systems. Let me show you some of them. And
I want to see one in the Lian Li snail case. That's what I want to see.
Grace Hopper, L40s, L4s, Bluefield 3s, just about every single processor that we're building are configured into these servers of all different types. And so this is Supermicro, this is Gigabyte, tens, I think it's like 70 different server configurations. This is Ingresys, this is ASRock, Tyan, Wistron, Inventec. Just beautiful servers. Pegatron.
Look at those. Just
love
beautiful.
Servers. I love servers. They're beautiful. They're beautiful to me.
Yeah.
QCT,
Tell that to all the ones that
we win.
At that bar you went to.
Mm-hmm.
I love the servers.
What you're looking at here is one of the pods of our Grace Hopper AI supercomputer. So I want to thank all of you. I want to thank all of you for your great support. Thank you.
You're welcome. I bought a 4090. You're welcome for my support.
We're going to expand AI into a new territory. If you look at the world's data centers, the data center is now the computer, and the network defines what that data center does. Largely, there are two types of data centers today. There's the data center that's used for hyperscale, where you have application workloads of all different kinds. The number of GPUs you connect to it is relatively low. The number of tenants is very high. The workload is heterogeneous. The workloads are loosely coupled. And you have another type of data center. They're like supercomputing data centers, AI supercomputers, where the workloads are tightly coupled. The number of tenants far fewer, and sometimes just one. Its purpose is high throughput on very large computing problems. Okay?
Mm-hmm.
And it's basically a standalone. And so supercomputing centers and AI supercomputers and the world's cloud, hyperscale cloud, are very different in nature. Ethernet is based on TCP. It's a lossy algorithm.
The real thing is, are you down with TCP?
Packet loss,
I know, right? Super exciting.
There's error correction that's done. It knows which one of the packets.
Thank you for joining us, PCMR.
And request the sender to retransmit it. The ability for
be sure to hit that like button.
To interconnect components of almost from anywhere is the reason why
you missed it. He talked about the 3060 Ti for like 4 seconds before he handed it back like it was like made out of bird crap.
So Ethernet's profound contribution. It's this lossy
capability, the world.
It's resilient capability,
well, unless the board game was Risk, then maybe you did miss it for the world.
However, a supercomputing data center can't afford that. You can't interconnect random things together because that $1 billion supercomputer, the difference between
you just bought one. And the more you bought, he said the more you buy, the more you save. You missed that.
Is effectively $500 million.
Oh, there you
go.
So
the cost of that one workload running across that entire supercomputer is so expensive that you can't afford to lose anything in the network. InfiniBand relies on RDMA very heavily. It is a flow control. It's a
Did he just say RDNA?
Approach. It requires flow control, which basically means you have to understand the data center from end to end, the switch to the NIC to the software.
It
So
sounded
that you
like it. I
can
was like, what?
orchestrate
What'd you say?
the traffic with adaptive routing so that you could deal with congestion
RDMA.
control
Oh,
and
okay.
avoid the
I smell a
oversaturation
lawsuit.
traffic in an isolated area, which results in packet loss. You simply can't afford that because in the case of InfiniBand, it's lossless. And so one is lossy, the other one's lossless. Very resilient, very performant. These two data centers
Very glossy.
have lived separate lives. These two data centers have lived separate lives.
Until today.
But now, we would like to bring generative AI to every data center. The
All
question
of
is
them.
how. The question is, how do we introduce a new type of Ethernet that's, of course, backwards compatible with everything, but is engineered in a way that achieves the type of capabilities that we can bring AI
Ginternet.
workloads to the world's
Nice.
any data center. This is
No, it's
a really exciting journey.
AI
And at the
internet.
core of this strategy is a brand
AI
new switch that
internet.
we've made.
AI internet.
This is the Spectrum 4 switch.
Oh my goodness.
And this
Sound effects.
switch,
Oh, come on. Yep. Waltz on over there. Jensen's not used to being in a room that's
everything I'm
bigger than
showing
his
today are
kitchen.
very heavy,
Oh, that means no GPUs.
like that.
Look at those heat pipes,
This is
though.
the Spectrum 4 switch. 128 ports of 400 gigabits per second, 128 ports of 400 gigabits per second, 51.2 terabits per second.
That's weak, man.
This is the chip. It's gigantic.
Show us the other side.
100 billion transistors.
I don't wanna
90
see the
millimeters
BGA.
by 90 millimeters. 800 balls on the bottom.
Yeah. Flip it around.
This
Don't show me your balls.
is a
Show me your chips.
500-watt chip. This switch is 2,800 watts. It's air-cooled. There are 48 PCBs that connect the switch together. 48 PCBs that build up the switch. And this switch is designed to, wait, punky out. Oh. This switch is designed to enable a new type of Ethernet. Remember what I said. InfiniBand is fundamentally different in the sense that we build InfiniBand from end to end. So that we can do
InfiniBand.
adaptive
That's it.
routing, so that we could do congestion control, so that we can isolate performance, so we could keep noisy neighbors apart, so that we can do in-fabric computing. All of these capabilities are simply not possible in a lossless approach of the internet and, of course, of Ethernet. And so the way that we do InfiniBand is design it from end to end. This is the way supercomputers are built. This is the way AI supercomputers are built. And we are going to do the same thing now for the very first time for Ethernet. We've been waiting for the critical part, and the critical part is the Spectrum 4 switch. The entire system consists of several things. So our new
Yep,
Ethernet
they did.
system for AI, is this. The Spectrum 4 switch and the Bluefield 3 Smart NIC or DPU. This Bluefield 3 is 400 gigabits per second NIC. It connects directly to the Spectrum 4 switch in combination of four things.
Yeah,
The
the
switch,
the GH200.
Bluefield 3,
96 gigabytes of
cables that
HBM3.
connect them together,
4
which
petaflops.
are super important, and the software that
72
runs it all
CPU
together
cores.
represents the
576
Spectrum 4.
GPU
This is what
memory.
it takes to build a high-performance network, and we're going to take this
It was
capability
wild.
to the world's CSPs. The reception has been incredible, and the reason for that is, of course, every CSP, every data center would like to turn every single data center into a generative AI data center. There are some people that they deployed Ethernet throughout their company, and they have a lot of users for that data center. The ability to have the capabilities of InfiniBand and isolating it within their data center is very difficult to do. And so for the very first time, we're bringing the capabilities of high-performance computing into the Ethernet market. And we're going to bring to the Ethernet market several things. First,
a new cord.
Adaptive routing. Adaptive routing basically says, based on the traffic that is going through your data center, depending on which
Poor
one of the
Jensen's gonna
ports
collapse.
of that
I feel
switch
like he's
is
like dying,
overcongested,
running back and
it
forth
will
on stage
tell
here.
Bluefield 3
Thank you.
and it will send it to another port. Bluefield 3 on the other end would reassemble it and present the data to the CPU, present the data to the computer, to the GPU, without any CPU intervention, all completely in RDMA. Number one, adaptive routing. Second, congestion control. Congestion control, it is possible for certain different ports to become
Anything is
heavily
possible.
congested, in which case the telemetry of the switch, each switch will see how the network is performing and communicate to the senders, please don't send any more data right away. because you're
Stop
congesting the
sending me
network.
pictures
That congestion
in my
control
DMs.
requires basically a overriding system, which includes software, the switch, working with all of the endpoints to overall manage the congestion or the traffic and the throughput of the data center. Now, it's really important to realize that in a high-performance computing application,
Stop sending me
every
chip
single
pics.
GPU must finish their job so that
He's sending you all the
application
chip
can move
pics.
on. In many cases where
On
you
the
do bulk reductions, you have to
InfiniBand
wait
network.
until the results of every single one. So if one node takes too long, everybody gets held back. This capability is going to increase Ethernet's overall performance dramatically. So Spectrum X, really exciting.
Can't wait to see it in my router
The world's
in 3 years.
applications, the world's enterprise has yet to enjoy generative AI. So far, we've been working
They're
with
just
CSPs.
depriving
And
themselves.
this CSPs, of course, is going to be able to bring generative AI to many different regions and many different applications and industries. The big journey is still ahead of us.
Oh,
There are so
L'Oreal,
many
because you're
enterprises in
worth
the
it.
world, and everybody, because of the multimodality capability that I was mentioning before, every industry can now
Can't wait to
benefit
have
from
a
generative AI.
AI
There's several things that we
developed
have to do.
recipe for McDonald's.
Number one, we have to help the industry
Can't get any worse,
build
right?
custom language models. Not everybody can use the language models that are available in a public service. Some customers need language models that are highly specialized for their particular modality. For example, proteins or chemicals. Each
Ooh,
one of these
Costco.
industries have proprietary
Can't wait to their
information.
generative AI.
So how can we help them do that?
Goodness.
We have created a service called NVIDIA AI Foundation. It is a cloud service that captures NVIDIA's AI expertise and makes it possible for you to
It makes it
train
beautiful.
your own AI models. We will help you develop your own AI models with supervised fine-tuning, with guardrailing,
And
with
it might
proprietary
just
knowledge
cost you
bases,
a whole
and
lot of
reinforcement
money.
learning human feedback so that this AI model is perfect for your application. We then deploy this model to run on NVIDIA AI Enterprise. This is the operating system that I was talking to you about earlier. This operating system runs on every single cloud. This allows this very simple system with NVIDIA AI Foundation for training large language models and deploying the language model into NVIDIA AI Enterprise, which is available in every single model, every single cloud and on-prem, allows every single enterprise to be able to engage. Now, one of the things that very few people realize is that today, there's only one software stack that is enterprise secure and enterprise grade. That software stack is CPU. And the reason for that is because in order to be enterprise grade, it has to be enterprise secure, it has to be enterprise managed, and enterprise supported across its entire life, across its life cycle.
That's
There are
enterprise
so much software
easy.
in accelerated computing.
It just works.
Over 4,000 software packages is what it takes
Jensen's
for
going
people
to start
use
talking about his
accelerated
package
computing
now.
today, in data processing and training and optimization all the way to inference. So for the very first time, we are taking all of that software and we're going to maintain it and manage it like Red Hat does for Linux, NVIDIA AI Enterprise will do it for all of NVIDIA's libraries. Now, enterprise can finally have an enterprise-grade and enterprise-secure software stack. This is such a big deal. Otherwise, even though the promise of accelerated computing is possible for many researchers and scientists, it's not available for enterprise companies. And so let's take a look at the benefit for them. This is a simple image processing application. If you were to do it on a CPU versus on a GPU running on enterprise, NVIDIA AI Enterprise, you're getting 31.8 images per minute, or basically 24 times the throughput, or you only pay 5% of the cost. This is really quite amazing. This is the benefit of accelerated computing in the cloud. But for many companies, enterprises, it's simply not possible unless you have this stack. NVIDIA AI Enterprise is now fully integrated into AWS, Google Cloud, and Microsoft Azure and Oracle Cloud. And so when you go and deploy your workloads in those clouds and you want software that is enterprise grade, or if you have customers that need enterprise grade software, NVIDIA AI Enterprise is ready for you.
We got you, baby.
It is also integrated into the world's machine learning operations pipeline.
Mlaps.
As I mentioned before, AI is a different type of workload. And this new type of software has a whole new software industry. And this software industry, 100% of them, we have now connected with NVIDIA AI Enterprise.
Lovely.
Now let me talk to you about the next phase of AI, where AI meets a digital twin.
Where AI takes over
now,
the
why
world.
does AI need a digital twin? I'm going to explain that in just a second. But first, let me show you what you can do with it. In order for AI to have a digital
How
twin,
long
are
are you going to keep talking?
Understand
Man.
heavy industry. Remember,
We've been
so far,
talking about
AI
digital
has only
twins
been
for the
used
past like
for
3-4
light
years.
Industry, information, words, images, music, so on and so forth. If we want to use AI for heavy industry, the $50 trillion of manufacturing, many of that you're part of, the trillions of dollars of healthcare, all of the different manufacturing sites, whether you're building chip fabs or battery plants or electric vehicle manufacturing factories, all of these would have to be digitized in order for artificial intelligence to be used to automate, to design, to build, and to automate the future of your business. And so the first thing that we have to do is we have to create the ability for their world
We need a digital
to be
twin.
represented in digital. Okay, so number one is digitalization. Well, how would you use that? So let me give you just a simple example. In the future, you would say to your robot, I would like you to do something, and the robot will understand your words, and it would generate animation. Remember, I said earlier, you can go from text to text. You can go from text to image. You can go from text to music. Why can't you go from text to animation? And so, of course, in the future, robotics will be highly revolutionized by the technology we already have in front of us. However, how does this robot know that the motion that it is generating is grounded in reality? It is grounded in physics.
It doesn't.
You need a software system that understands the laws of physics. Now, you've actually seen this already with ChatGPT. Whereas AI, NVIDIA AI, would use NVIDIA Omniverse as in a reinforcement learning loop to ground itself. You have seen ChatGPT do this using reinforcement learning human feedback. Using humans' feedback, ChatGPT was able to be developed by grounding it to humans' sensibility and align it with our principles. So reinforcement learning with human feedback is really important. Reinforcement learning,
Unless it was taught with a
physics feedback is
psychopath.
very important. Let me show you. Everything that you're about to see is a simulation. Let's roll it, please.
In fact, this whole presentation has been a simulation. This is not a movie. Interesting. Obviously false, because the Earth is round here, not flat. That was a joke. Here. Yeah, some of these visualizations are really good.
Everything was a simulation. Nothing was art. Everything was simulation. Isn't that amazing?
Or was it?
In the last 25 years, I come to Taiwan, you sell me things.
I'm changing that.
Omniverse will be the first thing I'm going to sell you. And this
First, you gotta know that the
because
more
this
Omniverse you
will help
buy,
you
the more you
revolutionize your
save.
business and turn it into a digital business and automate it with AI. You will build products in digital first before you make it physical. You will build factories and plan it in digital first before you make it in physical. And so, in the future, Omniverse is a very big deal. Now, I'm going to show you very quickly Omniverse in the cloud. Omniverse, the entire stack is so complicated. And so we put the whole thing into a cloud managed service, and it's hosted in Azure. This particular experience you're going to have, the computer is in California. And Sean, I'm sorry I took so much time, so you're going to have to
We'll go quick.
split.
So
Okay.
this is, let's take a look at the Omniverse Cloud. So this is, just a web browser, and we're looking now into Omniverse Factory Explorer. It's running 10,000 kilometers away in our Santa Clara headquarters, and we're leveraging the power of our data center now to visualize this factory floor. We're using real factory data from Siemens and Autodesk Revit to take a look. It's a cloud application, so we can have multiple users collaborating. Let's go ahead and bring up Eloise's screen, and we can see that we have these two users in this environment. And Jeff on the left there is going to look at some markup. We have this task to perform. We need to move this object. So we can have Eloise just go ahead and grab that conveyor belt, move it over, and as he does so, you'll see that it's reflected accurately and completely in real time on Jeff's screen. So we're able to collaborate with multiple users, and even in bringing up this demo, we had users from around the globe working on the process. East and West Coast, United States, Germany, even Sydney, and of course here in Taipei, to put this together. Now, if we're modifying our production line, of course, one of the things we want to do is add the necessary safety equipment. So we're able to simply drag and drop items into Omniverse and modify this production environment and begin tweaking this and optimizing for performance even before we break ground with construction.
That is so cool. This is in California, 6,264 miles away, or something like that. 34 milliseconds by speed of light one way. And it's completely interactive. Everything is ray traced. No art is necessary. You bring everything, the entire CAD into Omniverse, open up a browser, bring your data in, bring your factory in. No art is necessary. The lighting just does what the lighting does. Physics does what
just
the physics
works.
does. If you want to turn off physics, you can. If you want to turn on physics, you can. And multiple
If you want to
users with
simulate,
NVIDIA
you know,
Shield can
running a
enter
factory on
in
Mars
Omniverse at the same time
or
and work
running a
together.
factory on the moon,
One unified source
take
of data
advantage of
across
that
your
cheap,
entire
cheap
company.
moon
You
labor.
can virtually build, you can virtually design and build and operate your factory before you break ground and not make the mistake which usually in the beginning of the integration creates a lot of change orders, which costs a lot of money. Thank you very much, Sean. Good job.
Now, get out of here so I can talk
Not
more.
only, notice just now, it was humans interacting with Omniverse. Humans interacting with Omniverse. In the future, Sean will even have a generative
Sean
AI
will be
and
replaced by
interacting
AI.
with him in
Sorry,
Omniverse.
Sean, you're fired.
We could, of course, imagine in the very beginning there was Jin. That could be a character. That could be one of the users of Omniverse interacting with you, answering questions, helping you. We can also use generative AI to help us create virtual worlds. So for example, this is a bottle that's rendered in Omniverse. It could be placed in a whole bunch of different type of environments. It could render beautifully physically. You could place it just by giving it a prompt, by saying, I would like to put these bottles in a lifestyle photograph style backdrop of modern, warm farmhouse bathroom. Change the background. Everything is all integrated and rendered again. Okay, so generative AI will come together with Omniverse to assist the the creation of virtual worlds. Today, we're announcing that WPP, the world's largest advertising agency and advertising services company, is partnering with NVIDIA to build a content generation engine based on Omniverse and generative AI.
Oh, man.
It
Say
integrates
goodbye to your
tools
jobs,
from so many different other partners.
ad developers.
Adobe Firefly, for example, Getty, Shutterstock, and it integrates into this entire environment. And it makes it possible for them to generate unique content for different users for ad applications, for example. So in the future, whenever you engage a particular ad, it could be generated just for you. But yet, the product is precisely rendered because, of course, the product integrity is very important. And so every time that you engage a particular ad in the future, today, it was retrieved. And today, the computing model, when you engage information, it is retrieved. In the future, when you engage information, much of it will be generated. Notice the computing model has changed. WPP generates
I wonder when people are going to start putting prompts like Jensen Huang wearing only a leather jacket.
So they made a video of how they would use this technology.
The world's industries are racing to realize the benefits of AI. NVIDIA and WPP are building a groundbreaking, generative AI-enabled content engine to enable the next evolution of the $700 billion digital advertising industry. Built on NVIDIA AI and Omniverse, this engine gives brands the ability to build and deploy highly personalized and compelling visual content faster
Make sure that you hit like if you want to see Jensen Huang in just a leather jacket.
Using Omniverse Cloud, which connects product design data from industry standard tools. Then, WPP artists create customized and diverse virtual sets using a combination of digitized environments and generative AI tools by organizations such as Getty Images and Adobe, trained on fully licensed data using NVIDIA Picasso.
Just make your own. That's it. It's just that easy.
This unique combination of technologies allows WPP to build accurate photorealistic visual content and e-commerce experiences that bring new levels of realism and scale to the industry.
You down with WPP? Yeah, you know me. Was that real life? Uh-oh. Stuck pixels.
No problem. We continue. Okay, so that's WPP. You could see that was an example. If you think about it a second, that's an example of a company using digital information that was created in design and using that digital information all the way in marketing. I'm going to show you now how we're going to use Omniverse and AI here in Taiwan. And we're going to use it for manufacturing. Manufacturing, as you know, is one of the largest industries in the world. We're going to use Omniverse to teach in AI. And then we're going to use Metropolis, our AI deployment, edge deployment system, to deploy the AI. Okay, run it.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, planners can then optimize layout virtually before deploying changes to the real factory.
These planners aren't even real life.
The digital twin is also used as a training ground and data factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, along their production lines, which reduces cost and increases line throughput. NVIDIA
It is
Metropolis
terrible.
enables Pegatron
It
to
is
quickly
so
develop
boring.
and deploy cloud-native,
I was like
highly
hoping
accurate
like
AOI
something
workflows across their
gaming
production
wise,
lines.
but like there was like
Omniverse
5 minutes
Duplicator
of gaming
generates
stuff in the
synthetic
beginning,
datasets
and now
of
it's like
PCB
all
and
AI
defects,
because he
which are
knows
too
that
complex and costly
he's
to capture
making
in
the
one
money
video,
on the AI,
like
so
scratches and missing or misaligned
it's like just
components.
annoying.
Pegatron then combines the synthetic data with NVIDIA
It's like,
pre-trained
yes, we get
models,
it. AI.
NVIDIA Tau for training,
Come on.
adaptation, and optimization, and NVIDIA DeepStream for real-time inference, resulting in AOI performance that is 99.8% accurate with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
What's with this all white workforce?
Did you see that? The whole factory
Looks pretty
is in
bad.
Omniverse. It's completely digital. Imagine if you have digital information in your hands, what can you do with it? Almost everything. And so this is one of the things that's really exciting. What you just saw is basically every factory in the future will be digital, of course, first. Every factory will be a robot. Inside the factories, there will be other robots.
And there'll be no people, and you'll all have no
Factory
jobs.
is orchestrating. We are also going to build robots that move themselves. So far, the robots that you saw are stationary. Now we're going to also have robots that
Oh
move.
no, robots that
Everything
can move.
in the future will have artificial intelligence
Uh-oh.
and will have robotic capability. And so today we're
And they will
announcing
come and exterminate
our
you all.
robot platform, NVIDIA Isaac AMR, is now available as a reference design for anybody who wants to build robots. Just like we did with
Self-driving
high-performance
robots.
computing. NVIDIA builds the whole stack.
NVIDIA has
And
those
then we
day one drivers
disaggregate
for
it.
those
So that
robots.
if you would like to buy the chip, that's fine. If you'd like to buy the system, that's fine. If you'd like to use your software, that's fine. If you'd like to use our software, that's fine. If you'd like to use your own algorithm, that's terrific. If you'd like to use ours, that's terrific. However,
That's
you
even
would
more
like to work with
terrificer.
us, we're open for business, so that we can help you integrate accelerated computing wherever you like.
So you can
In
buy
the
more
future, we're gonna do
and
the same
save
with
more.
robotics. We built the entire robotic stack top to bottom, from the chip to the algorithms. We have state-of-the-art perception for multimodality sensors, state-of-the-art mapping, state-of-the-art localization
My
and planning,
goodness.
and a cloud mapping system.
Jensen, hurry up,
Everything
man.
has been created.
Come on.
However you would like to use it, you can use pieces of it. It's open available for you.
I was so excited when he's like, we're going to move real quick here.
So
And
this
then
is Isaac AMR. It starts with a chip called Orin.
he's doing his
It goes into
Isaac
a computer,
ASMR.
And it goes into the NVIDIA Nova Orin, which is a reference system, a blueprint for AMRs. This is the most advanced AMR
Like,
in the world today.
come on, man.
And that entire stack has been built. And let's take
I know, I'm like falling asleep too. I'm like yawning.
To improve productivity and increase worker safety, factories and warehouses are migrating away from manual forklifts and guided vehicles to full autonomy. NVIDIA Isaac AMR provides an integrated end-to-end solution to deploy fully autonomous
Speaking of moving
mobile robots.
boxes,
The core of
I've
the
got
solution
my
is Nova Orin,
water
a sensor
block
suite and
coming
computing hardware that enables mapping,
tomorrow
autonomy,
for my
and
4090.
simulation. Nova's collection of advanced sensors speeds
I'm
the
excited
mapping
about that.
process, leveraging our cloud-based service to generate
Am I
an
excited?
accurate and
I
detailed
know.
3D
Wow.
voxel map.
AliExpress
This
man
3D
for the
map
win.
Can then be sliced across a plane to generate 2D maps tailored for different autonomous robots that might operate in a facility. With these maps in place, on-robot LiDAR or cost-effective cameras
Yeah,
provide
I'm
autonomous
excited about it.
navigation that works reliably
Should be pretty
in the most
awesome.
complex and dynamic environments. Isaac Mission
It's
Control
true, it's not
optimizes
needed
route planning using the CUOP
unless you want to
library.
fit your
To improve
GPU in a smaller
operations,
case.
developers can use Isaac
That's
Sim
really
and
what it's
NVIDIA
all about for
Omniverse
me.
to create realistic digital twins of the operating environment.
It's not about reducing the
This allows
temperature of
fully
it.
autonomous robots to be trained on complex tasks entirely in
'Cause, yeah,
simulation.
No, the
All
cooler is like
operations can be
more
fully
than
validated
sufficient.
using Isaac Sim before
But it's like a
deployment to the real
4-slot cooler, right?
Isaac AMR
And the cooler
accelerates your
itself is like
migration to full
380 mil
costs and
long,
speeding
something
deployment
like
of the
that.
next generation of AMRs.
It's so, well, 350, 340, no, maybe 340 mil. Ridiculous though.
Nova cannot tell that it is not in the reality environment. Nova thinks it is in the real environment. It cannot tell. And the reason for that is because all the sensors work, physics work.
Nova
it
can't
can
tell
navigate, it can
because
localize
Nova's
itself.
dumb.
Everything is physically based.
No, Nova's smart.
therefore,
Nova's
we can
beautiful.
design-
You shouldn't be
we can
tricking Nova
design-
like that.
Wait.
Nova, remember me.
Therefore, we can design the robot, simulate the robot, train the robot, all in Isaac, and then we take the brain, Isaac Sim, then we take the brain, the software, and we put it into the actual robot. And with some amount of adaptation, it should be able to perform the same job. This is the future of robotics.
Yeah, I think my
Omniverse
water
and
block
AI
is gonna knock like, I don't know, like
the
probably
ecosystem that we have been in,
a good 4 inches off the length of my
is a quarter
GPU.
of $1 trillion per year. 250
It's gonna
billion
shrink it down to roughly the
This
length
is
of the
IT industry.
of the motherboard.
For the very first time in our history together, we finally have the ability to understand the language of the physical world. We can understand
Look at all
the
these different
language
companies
of
and
heavy
stuff
industry.
and
And we have
things.
a software tool, we have a software system called Omniverse that allows us to simulate, to develop, to build and operate our physical plants, our physical robots, our physical assets as if they were digitally.
Oh my.
The excitement in the hard industries, the heavy industries, has been incredible. We have been connecting Omniverse all
Not
over
gonna
the
lie
world,
though, I really
tools
like this
companies,
new
robotics
connector
companies, sensor
that comes on
companies,
these
all
NVIDIA
kinds of
GPUs.
industries. There are 3
The 12-volt
industries
high
right
power
now
one.
as we speak that's putting
It's so
enormous
nice and
investments
small, easy,
into the world. Number 1, of course,
one
the chip
piece
industry. Number 2, electric
that just
battery
plugs
industry.
in,
Number 3,
not
electric
3
vehicle industry.
6+2s.
Trillions of dollars will be invested in the next several years. Trillions of dollars will be invested in the next several years. And they would all like to do it better, and they would like to do it in a modern way. For the very first time, we now give them a system, a platform, tools that allows them to do that. I want to thank all of you for coming today. I talked about many things. It's been a long time since I've seen you, so I had so much to tell you.
You could have told
It
us from
was
your
too
kitchen,
much.
man. Come on.
It was too much. Last night I said, this is too much. This morning I said, this is too much. And now I realize it's too much. 凶贼啦.
Are you done? Yay, he's done. Let us clap.
I told you several things. I told you that we are going through 2 simultaneous computing industry transition, accelerated computing and generative AI. 2, this form of computing is not like the traditional general purpose computing. It is full stack. It is data center scale because the data center is the computer. And it is domain specific. For every domain that you want to go into, every industry you go into, you need to have the software stack. And if you have the software stack, the utility, the utilization of your machine, the utilization of your computer will be high. So number 2, it is full stack data center scale and domain specific.
It was
We are
like
in full
0
production of the engine of generative AI, and that is
0
HGX
gaming stuff. I was hoping for like some
Meanwhile,
gaming stuff.
This engine that's going to be used for AI factories will be scaled out using
I was
Grace
hoping
Hopper,
like for
the engine that we
well, I guess there
created
wasn't really
for the
much. I'm
era
surprised you
of
didn't talk about
generative
any of
AI.
the
We also took Grace Hopper
what is it?
and
The
realized
neural
that we can
texture
extend,
compression.
on the one hand, the performance, but we also have to extend the fabric so that we can make large.
And then we had to bend the
models
fabric
trainable.
of space-time.
Took Grace Hopper, connected to 256 node NVLink, and created the largest GPU in the world, DGX GH200. We're trying to extend generative AI and accelerated computing in several different directions at the same time. Number 1, we would like to, of course,
We would like our AI to be
cloud,
everything,
every cloud
everywhere,
data center
all
can
at
be
once.
an AI data center.
Okay.
Not just AI factories and hyperscale, but every hyperscale data center can now be a generative AI data center. And the way we do that is the Spectrum X. It takes 4 components to make Spectrum X possible. The switch, the BlueField 3 NIC, the interconnects themselves. The cables are so important in high-speed communications, and the software stack that goes on top of it. We would like to extend generative AI to the world's enterprise. And there are so many different configurations of servers, and the way we're doing that
My
with
goodness.
partnership with our Taiwanese
Please.
ecosystem, the MGX modular accelerated computing systems.
Wrap it up,
We put
Jensen.
NVIDIA in the cloud
Wrap
so
it
that
up.
every enterprise in the world can engage us to create generative AI models and deploy it in a secure way, in a enterprise-grade, enterprise-secure way in every single cloud. And lastly, we would like to extend AI to the world's heavy industries, the largest industries in the world. So far, our industry that all of us have been part of, has been a small part of the world's total industry. For the very first time, the work that we're doing can engage every single industry. And we do that by automating factories, automating robots, and today we even announced our first robotics full reference stack, the Nova Orin. I want to thank all of you for your partnership over the years. Thank you.
Thank you for finishing it.
I am here at Computex. I hope that you do like me best. Now my song's in a long thank you from NVIDIA.
The weird AI song. Well, that was that. And there wasn't really a ton other than NVIDIA. Honestly, though, some interesting things with AI. I am excited to see it to sort of translate into something a little bit more, let's say, yeah, something a bit more, what's the word I'm looking for here? Something more like in the realm of like game development. I'd love to see more of that, and just to see that AI being used to speed up game development, to enhance game development, to even like create and develop mods for current games. And I think in the future too, like, you know, you're looking at like different games and, you know, people are like, oh, the devs are lazy, it's using so much resources. It's like, well, you know, why don't they just, you know, use AI to, I don't know, figure out how to do it in a more efficient manner. So I'm thinking there's a lot as far as, you know, speeding up game development. That can definitely be happening at a much higher rate thanks to AI. But yeah, we'll see. Just want to say too, thank you for everybody for stopping by, for watching. Make sure you hit that like button. It's every like helps. I want to say thank you for stopping by, PCMR, for staying up. Moody Ali, thank you for coming hanging out. I think you did sub to the channel, so big thank you to you for that. Salty Nutella, it was awesome having you here on stream, and just chilling, throwing out some of your good stuff in there. You made the stream a lot of fun. And you too, Helly. I don't know what you did, but you stopped in and you said skull. So cool. I'm down with that too. But yeah, I hope everybody has a great night. I'll probably see you all tomorrow night. I'm gonna be streaming something. I was gonna do a game, but I've got a couple of pieces of old hardware that I just want to tear into. Actually, you know what? Tomorrow night, I think I might do an unboxing of my GPU water block. So we might take a little peek at that. So stick around. And thank you for subscribing, and I'll see you guys in the next one. Alrighty? All right. Bye. There is no outro music. Except for... Wait for it. Wait for it. We're going to do the outro music. Right? Here's the outro music right now.
Computex. I hope that you do like me best. Now my song's in a long thank you from NVIDIA. I am here at Computex.